Why the universe has no center point, the place where it all began. Go ahead, try to point to the exact spot where the Big Bang occurred. Whatever direction you choose, you are pointing the wrong way. It does not matter which way your finger aims. You are incorrect. The Big Bang did not take place somewhere out there in the distance. It did not occur at one particular location. This immense arrangement of galaxies, dark matter, radiation, and vacant space simply possesses no center. There is no middle. There is no edge. There is no privileged site where everything originated. I realize that sounds impossible. I know it collides head-on with everything your mind is insisting right now. If the universe grew outward from a minute point, that point must be the center, right? Surely everything is rushing away from some origin, some cosmic ground zero. That is what the word explosion suggests. That is the image the phrase Big Bang conjures, a bomb detonating inside empty space, fragments flying outward from a single site. And that mental picture is completely, fundamentally, spectacularly mistaken. I am Leonard Susskind, and for more than 50 years I have thought about the architecture of the universe. I can state with absolute certainty that the lack of a center is not a minor technical footnote. It is one of the most profound and unsettling facts about the cosmos. It alters what the universe itself is. It alters what space is. Once you grasp it, you will never regard the night sky in the same way again. Let me begin by showing why ordinary intuition collapses here. When people hear that the universe is expanding, the brain does something automatic. It pictures a balloon being inflated, or a bomb going off, or a crowd of people fleeing a building. In every one of those examples, there is a center, the middle of the balloon, the location of the bomb, the building everyone is running from. Those are events occurring inside a space that already exists. The debris travels through space, departing from a point that already sits inside that space. The expansion of the universe is nothing like any of those things. The universe is not expanding into some larger container. There is no pre-existing emptiness that the universe is gradually occupying. What is expanding is space itself. Every location is moving away from every other location. Not because objects are racing through a fixed arena, but because the space line between them is growing. That distinction is essential, and most people miss it completely. Here is an analogy that works a little better than the familiar balloon, though no analogy is perfect. Picture an infinite sheet of rubber, not a closed balloon surface, but a flat sheet that stretches forever in every direction. Now imagine that this rubber is being stretched uniformly everywhere at once. Every point on the sheet recedes from every other point. If you are an ant standing on that sheet, you look around and watch every other ant moving away from you. The more distant an ant is, the faster it appears to flee. You might decide that you occupy the center, that everything is expanding outward from your position. Yet every single ant on that infinite sheet observes exactly the same thing. Every ant concludes it is at the center. Every ant sees all the others receding. No ant is special, and there is no center to the stretching, because the sheet is infinite and the stretching is the same everywhere. That is what cosmic expansion resembles, except the space is three-dimensional rather than two-dimensional. And as far as present evidence indicates, the universe may truly be infinite. Now let me clarify what the Big Bang actually was, because this is where confusion is deepest. The Big Bang was not an explosion that happened inside space. It was an event in time, the moment when the entire universe existed in an extremely hot, extremely dense condition, not concentrated at one point in space, but everywhere. Every region of space that exists today was 13.8 billion years ago, hot and dense. If the universe is infinite now, it was already infinite then. An infinite volume can be uniformly hot and dense. There is no logical contradiction. It simply means that every cubic centimeter of that infinite space was packed with energy. Reflect on that for a moment. The Big Bang did not occur at a particular place. It occurred at a particular time. It occurred everywhere at once. Every point in the present universe can follow its own history backward 13.8 billion years to that same state of extreme heat and density. No point stands closer to where it happened, because it happened at all points. That is what Einstein's general relativity implies. That is what the Friedman equations describe. That is what the cosmic microwave background confirms. The universe has no center precisely because the Big Bang had no location. Let me present the evidence, because this is not mere theoretical speculation. We can observe that the universe lacks a center. The strongest single piece of evidence is the cosmic microwave background radiation, the CMB. This is the afterglow of the Big Bang. Roughly 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Before that moment, the cosmos was a plasma, a seething mixture of free electrons and protons so hot and dense that light could not travel freely. Photons scattered off free electrons almost instantly. The universe was opaque, like being trapped inside a dense fog. Then, when the temperature fell to about 3,000 Kelvin, electrons combined with protons to create neutral hydrogen atoms. Suddenly, the universe became transparent. Light could stream across vast distances. The photons released at that instant have been traveling ever since. Cooling as space itself expanded, their wavelengths stretched from visible light into the microwave range. Today, those photons fill the entire universe. They arrive from every direction, and they are almost perfectly uniform. The temperature of the CMB is 2.725 Kelvin, identical in every direction to better than 1 part in 100,000. That uniformity is extraordinary. It tells us that 380,000 years after the Big Bang, the universe looked essentially the same in every location. There was no center, no edge, no preferred direction. Only a smooth, hot plasma filling all of space evenly. If the Big Bang had occurred at one specific site, we would expect a gradient in the CMB, hotter radiation in the direction of the supposed explosion, cooler radiation opposite it. We would detect a bullseye pattern, a clear signature of a center. We see nothing of the kind. The CMB is isotropic, the same in all directions. That is precisely the pattern expected if the Big Bang happened everywhere, and the universe possesses no center. There are, of course, tiny fluctuations in the CMB, temperature variations of roughly 1 part in 100,000. Those fluctuations matter enormously. They are the seeds from which every structure we see today grew. Galaxies, galaxy clusters, cosmic filaments, and voids. Yet the fluctuations themselves are random. They are scattered uniformly across the sky, showing no preferred direction and no preferred location. Statistical analysis of the CMB demonstrates that the fluctuations match a Gaussian random field, exactly the pattern predicted by inflationary cosmology for a universe that has neither center nor edge. Let us go deeper still, because the geometry of the universe is where the idea becomes truly strange and fascinating. In general relativity, the geometry of space is fixed by its contents, matter and energy curved space-time. The overall shape of the universe therefore depends on its total density. 3 possibilities exist. If the density exceeds a critical value, space is positively curved, like the surface of a sphere. It is finite, yet has neither boundary nor center. You can travel forever on a sphere and never encounter an edge. Every point is equivalent to every other. If the density falls below the critical value, space is negatively curved, like an infinite saddle. Again, there is no center. If the density equals a critical value exactly, space is flat. Ordinary Euclidean geometry extending infinitely in every direction. No center. Measurements, drawn primarily from the CMB but also from galaxy surveys and supernova observations, show that the universe is extremely close to flat. The density lies within about 0.5% of the critical value. Consequently, space is either precisely flat and infinite, or so nearly flat that any curvature is far too slight for us to detect. In either case, there is no center. Here is what unsettles people. If the universe has no center, where exactly are we? What is our position within the cosmos? The answer is that we occupy a perfectly ordinary location. The Copernican principle, named for Nicholas Copernicus, who demonstrated that Earth is not the center of the solar system, extends to the entire universe. Earth is not the center of the solar system. The Sun is not the center of the Milky Way. The Milky Way is not the center of any larger structure, and no galaxy, no cluster, no supercluster sits at the center of the universe, because no such center exists. This fact runs contrary to deep human psychology. We evolved to think in terms of centers and edges. Our personal world has a center, the place where we stand, and it has edges, the horizon, the borders of our territory. Instinctively, we place ourselves at the middle of experience and then project that habit onto the cosmos. The universe, however, is indifferent to our psychology. It possesses its own geometry, and that geometry contains no center. Now consider something that confuses even physics students: the observable universe. The observable universe is a sphere centered on us with a radius of roughly 46.5 billion light years. You might object, if the universe is only 13.8 billion years old, how can the observable radius be 46.5 billion light years? Should it not be 13.8 billion? The answer is no, because space is expanding while light has been traveling. Light that left a distant galaxy 13 billion years ago has journeyed through continuously stretching space. During that entire interval, the galaxy itself has been receding from us. Today, that galaxy lies about 46.5 billion light years away, even though the light required only 13 billion years to arrive. The observable universe is a sphere centered on us solely because we're the observers. It is not a physical boundary. It is an informational boundary, the region from which light has had time to reach us since the Big Bang. An observer on a planet in the Andromeda galaxy would possess a different observable universe centered on that planet. The two spheres would overlap enormously, yet each would extend 46.5 billion light years in every direction from its own location. That observer would see galaxies we cannot see, and we would see galaxies that observer cannot see. Neither of us occupies the center of anything. Each of us simply sits at the center of our own observational horizon. I must now address the expansion itself, because this is where the absence of center becomes most vivid and most counterintuitive. In 1929, Edwin Hubble discovered that distant galaxies are receding from us. The greater the distance, the greater the speed of recession. This is Hubble's law, expressed by a simple relation. Recession velocity equals the Hubble constant multiplied by distance. At first glance, the pattern looks exactly as though we stand at the center of an explosion, everything flying outward, faster the farther away it is. The crucial insight is that Hubble's law appears identical from every point in the universe. An observer in the Andromeda galaxy would see all other galaxies receding from that location. An observer in a galaxy 10 billion light years away would see the same pattern. Every observer finds himself or herself at the apparent center of expansion. This is a purely mathematical consequence of uniform expansion. When every distance increases by the same fractional amount in a given time, every observer necessarily sees every other point receding at a speed proportional to distance. No center is required. Return to the infinite rubber sheet analogy. Every ant watches every other ant recede. The speed of recession is proportional to distance. No ant occupies the center, because there is none. The stretching is homogeneous. Let me introduce the cosmological principle, one of the foundational assumptions of modern cosmology, and one that observation has confirmed to extraordinary precision. The cosmological principle asserts that, on sufficiently large scales, the universe is both homogeneous and isotropic. Homogeneous means it looks the same at every location. Isotropic means it looks the same in every direction. Together, these properties guarantee the absence of a center and of any preferred direction. On small scales, the universe is, of course, lumpy. Stars, galaxies, clusters, voids, and filaments create a highly non-uniform distribution of matter on scales of millions of light years. Zoom out, however, to hundreds of millions of light years or more, and the lumpiness averages away. The distribution of galaxies becomes smooth and uniform. Surveys such as the Sloan Digital Skies Survey, which have mapped millions of galaxies, confirm that above roughly 300 million light years of universe is remarkably uniform. No special structures, no edges, no walls, no center. Here the discussion turns philosophically deep. If the universe has no center, what does that imply for us? What does it say about our significance within the cosmos? For most of human history, we believed we stood at the center. Earth was the middle of everything. The sun and stars revolved around us. We were special. Copernicus displaced us from the center of the solar system. Later we learned that the sun is an ordinary star inside an ordinary galaxy. Still later we learned that our galaxy is one among hundreds of billions. Now we learn that there is not even a center from which we could be displaced. There is no throne at the middle of the cosmos that we have been removed from. The throne never existed. Every point is as central as every other point, which means that no point is central at all. Some people find this depressing. The universe is no center, therefore we are nowhere special. I prefer a different perspective. Every point in the universe is equally valid. Every location is as fundamental as any other. Right now, wherever you stand, you occupy a point that is exactly as central, exactly as significant, exactly as original as any other point that exists or has ever existed. You are not on the outskirts. You are not on the periphery. You are not displaced from some cosmic midpoint, because there is no outskirts, no periphery, and no midpoint. You are here, and here is as good as anywhere. Let me speak about inflation, the theory that most convincingly explains both why the universe has no center and why it appears the way it does. In the early 1980s, Alan Guth proposed that the very early universe underwent a brief period of exponential expansion. In a tiny fraction of a second, space grew by a factor of at least 10 to the power of 26 and possibly far more. This inflationary epoch solved several long-standing puzzles. It explained the extreme uniformity of a CMB. Regions that today appear causally disconnected were once in causal contact, before inflation stretched them far apart. It explained the near flatness of the universe. Inflation drives geometry toward flatness regardless of the initial curvature. And it explained the origin of the density fluctuations. Quantum fluctuations in the inflating field were stretched to cosmic scales by the rapid expansion. Inflation carries a further profound implication for the question of centers. If inflation occurred, the observable universe is merely a tiny patch of a vastly larger whole. Imagine the universe as the surface of a balloon inflated to an absurd size, so large that any local patch looks perfectly flat. You cannot detect the global curvature because the balloon is enormous. Our observable universe is like a postage stamp on that surface. We see a small flat region and conclude that the universe might be infinite and flat. It might be, or it might be finite yet unimaginably large, with curvature so slight that it remains undetectable. In either case, we inhabit a minute patch of something far greater. Inside that greater volume, there is certainly no center. Every patch resembles ours. Every region shares the same density, the same temperature, the same physics. Neither we nor our patch is special. No geometric feature singles out any location as different from any other. I want to answer an objection that careful thinkers sometimes raise. What about the cosmic microwave background? You said it looks the same in every direction, yet there is a dipole and isotropy. The CMB is slightly hotter in one direction and slightly cooler in the opposite direction. Does that not define a special direction, perhaps a center? No, the dipole is produced by our motion relative to the rest frame of the CMB. Earth, the Sun, and the Milky Way are all moving through space at roughly 370 kilometers per second relative to the frame, in which the CMB is isotropic. That motion creates a Doppler shift, warming the radiation in the direction of travel and cooling it in the opposite direction. Once the dipole is subtracted, the CMB is isotropic to 1 part in 100,000. Our velocity defines a speed, not a position. It tells us how fast we are moving, not where we stand relative to a center, because no center exists. Let me bring in an idea from my own research, because it connects to the present discussion in a striking way. Consider the string theory landscape and the multiverse. If the inflationary multiverse picture is correct, and I have spent much of my career arguing that it may well be, then our universe is only one bubble in an infinite foam of bubble universes. Each bubble nucleates from a different vacuum state in the string landscape and may possess different physical constants, different particles, and different forces. In that picture, the question, where's the center of our universe, becomes even more meaningless. Our universe is a bubble inside an infinite, eternally inflating space that continually spawns new bubbles. There is no center to the foam, no edge, no preferred location. Inside each individual bubble, the same story repeats. No center, no edge, no special point. Homogeneity all the way up. Let me return to ordinary human experience, because I want to consider what this means for you, for your life, and for the way you think about your place in the cosmos. You live on a small, rocky planet orbiting an ordinary star inside an ordinary galaxy. There are roughly 200 billion stars in our galaxy and roughly 2 trillion galaxies in the observable universe. The total number of stars in the observable universe is on the order of 10 to the power of 24, a trillion. Every one of those stars, every planet around them, and every atom in every planet occupies a location that is exactly as central to the universe as your own location, because there is no center. You might conclude that this renders you insignificant, a speck on a speck inside a centerless expanse. I believe significance was never about location. The medieval claim that Earth sat at the center of the universe did not make human life more meaningful. It was merely a geometric assertion, and it was false. Our significance arises from something else entirely. We are the only known portion of the universe that is aware of the universe. We are matter that has organized itself so that it can ask questions about its own origin. Stars do not wonder where the center is. Galaxies do not inquire whether they are special. Dark matter does not contemplate its own existence. We do. That capacity, not our coordinates, is what makes us remarkable. What I find most beautiful about a universe without a center is its democracy. No civilization anywhere in the cosmos, if other civilizations exist, can claim a more fundamental location than any other. Every observer, wherever situated, sees the same large-scale universe, the same expansion, the same CMB temperature, the same laws of physics, the same fundamental constants. The universe presents an identical face to everyone, independent of location. That is an extraordinary statement about the nature of reality. It means the laws of physics are truly universal, not metaphorically, but in a literal geometric sense. There is no privileged frame, no special site where the laws are written and from which they radiate outward. The laws are everywhere. They're the same everywhere. That universality, that deep symmetry of homogeneity and isotropy, ranks among the most profound discoveries in the history of science. Could I be wrong? Could the universe actually possess a center that we have simply failed to detect? In science, we must always hold conclusions provisionally. Yet the evidence is overwhelming. The CMB is isotropic. The large-scale distribution of galaxies is homogeneous. The solutions of general relativity for a uniform universe contain no center. Inflation predicts no center. Every line of evidence points in the same direction. The universe has no center. Exotic possibilities remain. Some cosmologists have examined models with non-trivial topology, a universe that wraps around on itself like a torus. In such a geometry, space is finite, yet still lacks both center and edge, just as the surface of a donut has neither. You can travel indefinitely and eventually return to your starting point. Searches for the telltale repeating patterns that would reveal such a topology in the CMB have so far found none, though the possibility has not been entirely ruled out. Even if the universe possesses exotic topology, it would still have no center. A torus has no center. A Klein bottle has no center. None of the compact topologies considered by cosmologists possesses a center. The absence of a center is robust. It survives every model, every topology, every variation of the theory. I will leave you with this. The next time you look up at the night sky, resist the impulse to regard yourself as occupying any particular place relative to the whole. You are not at the center. You are not at the edge. You are not at any definable position with respect to the totality, because the totality has no reference point. You are simply here, a conscious being composed of atoms forged inside ancient stars, standing on a rocky planet inside a galaxy among trillions, inside a universe that extends in every direction without beginning or end in space. The Big Bang was not a location. It was a moment. It happened everywhere. It happened at the very place where you are standing right now. The ground beneath your feet was present at the Big Bang, compressed to unimaginable density, hotter than the core of any star, 13.8 billion years ago. You are standing at the site of the Big Bang, and so is everyone else, and so is every point in the universe. That is the deepest truth about cosmic geography. There is no center, because everywhere is a center, or nowhere is, depending on how you choose to phrase it. After 50 years of studying the structure of the universe, of working through the mathematics of general relativity, quantum field theory, and inflationary cosmology, this is the realization to which I continually return. We are not at a special place. We are at every place. We are the universe examining itself from one of infinitely many equivalent vantage points. And we are the only part of the universe that knows this. We are the cosmos comprehending its own geometry. That understanding, that awareness, is more central than any location could ever be. Thank you for listening. Now step outside and remember, wherever you happen to be, you stand exactly at the center of everything and at the same time nowhere at all. That is not a contradiction. That is the universe.